Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com.
Hello and welcome to this week's episode of Better Buildings for Humans. I am your host, Joe Menchefski, and this is the podcast where we look at the impact that the built environment has on our health, our wellness, our happiness, our productivity, our general joy of being alive. And of course, we talk about productivity and we talk about efficiency as well. This week, I have a special guest. I have Gene Eidelman from Azure Printed Homes. Gene, welcome to the show.
Thank you, Joe. Thanks for interviewing me.
Well, it's an absolute pleasure. I can't believe I haven't talked about 3D printing yet, so I'm glad I finally get to have this conversation. Let's start by letting our listeners learn a little bit about you and your background. Maybe tell us a little bit about that background with an emphasis on the path that led to you creating Azure Printed Homes.
Sure. Well, so I'm originally from Ukraine. I came to the U.S. as a refugee from former Soviet Union, so I left after high school. And a year after being in this country, started selling real estate initially, and then soon enough, my brother and I started developing. So I've been doing this for 35 plus years. All these years, I've been very frustrated with how long it takes to build, the cost of building. And so 5 years ago, started a construction company with my business partner. And our goal was to find a way to build faster, less expensive, and with less environmental impact. And then almost 3 years ago, so it took us a couple of years of trying, playing, and almost 3 years ago, printed our prototype. And last year started delivering units, and this year moved into a brand new factory. I'm sitting in it right now with triple capacity. So that's been kind of the path.
That's incredible. Faster, less expensive, and less environmental impact. That's a very ambitious goal, and I tip my hat to you for that. Okay, so let's dive right in and learn. So Azure is a little more than a typical printed home operation, but before we get into that, let's talk big picture. Let's make sure people understand the basic concepts. What is a printed home? How is it done?
Sure. So we have three 3D printers behind me. I don't know that you can see it, but it's basically a robotic arm with an extruder. Extruder is a mechanism that melts the pallets into a substance that kind of layer by layer lays the building walls. The substance itself is 60% the recycled plastic, 40% fiberglass. It's fiberglass that has rigidity to the building. Plastic really acts as a resin that connects the layer to layer. And we're a modular manufacturer, so our buildings are made in our factory. The process of printing the module itself is very fast. It takes under 24 hours to print our modules, different sizes. And then it takes 1 to 4 weeks to finish them. That also happens in the factory. So all the MEP, all of the electrical, mechanical, plumbing is done in the factory. And so when the units leave the factory, they leave on the back of the truck. And if it's just a smaller unit, it's just delivered totally finished. It just gets attached to foundation and attached to utilities on site. If it's a larger building that consists of multiple modules, then the connection of the modules happens on site. So if it's a single modular, it takes about 4 hours to install it. If it's multiple modules, depending on the size, it could be 2 to 3 days to connect them all and get a finished product.
So in the worst case scenario, you're literally looking at maybe from 5 weeks from somebody saying go until the point where they have something fully finished on.
Yeah, with our customers, you can order it this month and move in next month, which is, it's kind of normal for buying a car, but totally impossible for buying a house, right?
That's extraordinary.
If you think about it, 100 years ago, we had a horse and a buggy, and now we have EV vehicles, right? 100 years ago, we had carpenters with a hammer and a nail building a house, and in many places, it's still done the same way. So construction industry has just been very slow to innovate, and the time has come. It had to happen sooner or later. I believe now the time has come to accelerate. And of course, we'll talk about other things, but it's just a new way to build this.
Well, given those sorts of numbers, it really is incredible. I mean, so the build time is breathtaking. What about the cost? How does it compare to, an equivalent to sort of stick build?
Sure. So the cost here, we are in Southern California, and majority of our deliveries so far have been in California. We are 30% under what it costs to build a traditional building. I mean, if you think about it, we use no lumber, we use no roof. So we print the two walls, the floor, and the roof. So basically, one print replaces like 6 trades. We have no sheathing. There is no need for waterproofing because it's a solid
Continuous.
structure.
Yep.
So the costs are significant, and more importantly, it doesn't fluctuate, depending on supply chain. I mean, there is plenty of plastic in this world. The world produces 400 million metric tons of plastic every year. Less than 5% gets recycled. So there is lots of plastic to be recycled, to be used for us. This year alone, in 2024, we used 250,000 pounds of plastic. And our goal by next year is to use close to 1 million pounds of recycled plastic. So there is plenty of core material, and it doesn't fluctuate. If anything, it should be coming down because of access. Yeah.
Do you want to bring lots of healthy, beautiful natural light in your building and still meet energy codes? Try Solera from Advanced Glazings. Learn more at advancedglazings.com.
Yeah, okay, so that's amazing. Now, obviously, there's a strong sustainability component in that you're removing, plastics that otherwise would have ended up in a landfill or burned, and you're using it productively. So that's a very strong contribution to, a more sustainable world. What about like the heating and cooling of the printed homes, of the Azure homes?
Everything else you can think of is just like a traditional house, because what happens is we print 2 walls every time there's a print. The printer goes, it prints the outside wall, and then on the way back, it prints the inside wall. So we leave the space between the interior and exterior walls for insulation and for plumbing and heating. So we create channels, what we call them, just basically areas where we can put all of the MEP and insulation. And the fact that 3D printing process itself is very flexible. When we do it for California, we exceed the insulation standards here. Here, the standard is R30 in the ceiling, R19 in the walls. We do R30 all the way around. But if we were to print for Canada or New England, we would go with what's requirement. Usually in a lot of areas, R48. So instead of leaving 6 inches between the walls that achieves R30, we leave 8 inches in between the walls that achieves a higher insulation. So the units are very well insulated and also very quiet because they're just the air.
Right.
So, yeah, the flexibility of 3D printing process allows us not only to make units that are, that can work in different environments, but also can create all kinds of interesting shapes. I mean, we are not limited by a 2x4. So we don't do many of the square or rectangular buildings. So we are able to do curves and makes them very attractive.
So Frank Gehry would have loved you guys. He would have.
Well, if you think about great structures, you think about Colosseum or Taj Mahal or what Frank Gehry did.
Yeah.
None of it is rectangular or square, right?
Right.
And I mean, we've gone to much, the structures just primarily because of cost, right? You can still see some, office buildings that use curves, but generally it increases the price by 30-40%.
Right.
For us, it really is doing curves is easier than doing straight corners.
Right. Yeah, of course. Yeah.
The way printer works.
So if you wanted to drill a hole because you needed to run some electrical cable or something like that, you just drill right into the wall. It's no issues.
What happens was on the interior, we actually use panels or drywall. So the interior of the building is just like any house. So you will not be drilling into the material. You'll be drilling into the interior wall.
Okay.
And then because we only print 4 sides, the front and back of the building are done traditionally. We use a cement board or, just the front and the back is more traditional. That allows us more flexibility into. You can have a slider door, you can have a regular door, and you can have more windows, less windows. So the flexibility really in terms of openings are in the front and the back of the building. But the two sides and the roof and the floor is we prefer not to have penetrations. We are now working on a building where we'll connect two buildings on the printed side, but that's going to be accomplished just by design so that we don't print the door open.
Okay. What about lifespan? Plastic materials subject to UV, bombardment of UV light. How long are you anticipating the lifespan?
Yeah,
What
yeah,
is
yeah.
the lifespan of the
So
building?
we apply, after the building is printed, we apply UV stabilizer and fire retardant material in the stain. We work with major paint company. They give a 15-year warranty on the color. So UV is just not an issue. The fire retardant material has its own ICC code. Again, it's been tested. And before we started printing anything, we did longevity tests. So, whenever you use new material for construction, there's a pretty lengthy process to get this approved. So we got working with ICC, we received basically kind of developed standards that can be used and then tested for longevity testing. So we can do, in 100 days by changing temperatures up and down, pretty radical temperature changes. We've been determined that material will last. So we produce these units in California, which is one of the highly regulated tests. We are required to give a 10-year structural warranty. But, plastic will actually last for a very long time. And the reality is it's a fiberglass that adds the rigidity. And of course, fiberglass is now used instead of iron rods in cement. So it's a very strong material. And using UV stabilizer and fire protection material, we eliminate some of the issues that plastic might have. We also, Joe, use PETG. It's plastic that's used in water bottles and food containers. That's a material that's had the most testing for safety. So it doesn't off-gas. And of the, I've used these numbers of how much plastic there is. 20% of the plastic that's produced is using PETG or PET that's used for food containers, water bottles. So there's plenty of the plastic that is the safest for humans. And there are no off-gassing issues. Tested air quality in our units. There's just absolutely no issue.
Okay. Now let's talk about the market a little bit. Who is buying your homes and why are they choosing it? I mean, I see a lot of good reasons, but I'd like to hear what your
Yeah,
customers are telling you.
yeah. This is my fourth startup, and I often tell this story. In the previous three startups, I thought of an idea, I built it, and then I convinced other people to buy it, right?
Right.
Here, it was a little bit of a reverse process. Even before we finished our first prototype, we put an image of what we thought that we'll be able to do. We put it on the Facebook. And we did 3 months before we produced our first prototype. And orders started to roll in. I've never experienced anything like this. And so while we posted just an image of a little backyard studio, no plumbing, just a little 120 square feet. In the US, I think kind of the same, anything under 120 square feet considered a shed, right? In most of the states. But our initial vision, we did it during COVID, right? So during COVID, when people worked from their homes, our initial vision was to create the studios as our go-to-market product that people could use in their backyards to work virtually. But simultaneously with us rolling out this product, California has been improving its ADU laws. ADUs are homes that you can build in the backyard, either for additional family members or for rental purposes. And ADUs is where it's been the biggest demand. ADUs and affordable homes. I'm actually, after talking with you, I'm going to be jumping in a car and driving to Northern California. And we have a developer who is going to build a small 10-unit subdivision of affordable homes using our product. We also have a letter of intent signed in Colorado where a developer is going to do 100 homes that are in the affordable category. So the main demand is from ADUs and affordable homes. And again, it wasn't necessarily expected, but we kind of sense that's where demand will come from. But the surprising uses were one of our first installations was for a glamping resort. There's a glamping resort called Three Bones in Big Sur. And when the owner of that project, very entrepreneurial guy, when he saw this image, he jumped on his Harley, drove down to our factory. So that one of your first ones. And it's a unit that generally retails for about $40,000. He took every upgrade. He doesn't have electric there, so he wanted to have solar and a battery. He wanted to have real upscale finishes on bathrooms and kitchens. So for a unit that retails for 40, with all the additions, it was $60,000. Once he installed it, it runs for $750 a night and pre-sold for 6 to 9 months in advance. So he got his money back in the first 4 months. So glamping industry has been a huge surprise. Quite honestly, when he first came and told me about glamping, I didn't know. Again, it shows you the limit of my English. I didn't know what glamping was. And I'm not a camper. So
it's a fairly new term in your defense. Right. It's a fairly new term.
But since then, we have all the way from San Diego to Arkansas. We've had our guys in the back there working. We have an order for 25 of these units to go to glamping units around the country. We've shipped a couple to Arkansas last week, and then this week we're shipping some to Northern California. The beauty of putting them in glamping resorts is now when somebody from Northern California is asking, well, do I have to fly down to LA to see how your finish looks? And we don't look. Why don't you just stay for a couple of nights at the Three Bones and experience it yourself? And so the beauty of having units in these glamping resorts is as we move forward, there's going to be many places where people can just go in their area and stay at one so they can experience the quality of issues. So that's kind of on the upper end. On the lower end, from what we initially envisioned, is housing for the homeless. So we have a tremendous problem in LA. We have 75,000 homeless just in LA County alone. We're hosting World Cup in 2 years and Olympics in 4 years. And quite honestly, it's going to be very embarrassing if all the visitors from around the globe will see the extent of our issues. And the number is too big for us to go chip them out somewhere. So there is a new law that passed in California and was signed by governor in September that allows interim housing. Usually solutions for the homeless have had two extremes. Either, places where people can just go spend the night, like shelters, or permanent housing. Permanent housing takes 6 years to build and $800,000 per unit with the numbers we have. That's uneconomical. Yep. So having units that we sell for $20,000 is a huge advantage. And we've already signed the contract, but early in January we'll be announcing our first tiny home tiny home area here in California, and we see a lot more of that. Next week, I'm flying to North Carolina. Asheville suffered, hundreds of homes were destroyed in floods. Yep. So using our homes for emergency housing, after natural disaster, or workforce housing. Again, there are many plants going up, all the way from Texas for SpaceX to Ohio for a new Intel factory, where there is just a need for these construction jobs, and hotels have become very expensive. So using our units, the beauty is, first of all, we can make them on wheels, so they can literally come, be used, and then be relocated somewhere else. But even if they get attached to foundation, they're very light and they're very easy to install, and then to lift them up and move them somewhere else. So the range, we kind of sell into 5 verticals. Right. It's been pretty incredible. The product market fit that a lot of startup entrepreneurs looking for. This is the first time I've experienced something that happens naturally, so that feels great.
Oh, it's wonderful. Let me talk about expansion a little bit. I'm going off script a bit, Gene, but what's the growth model in that? Like, are you going to expand your factory in California, or is it smarter to put a factory in the Northeast and the Southeast in Canada, PNW?
Yeah. Truly, to be true to our sustainability focus, we need to move factories closer to customers, because trucking these units around the country just doesn't make sense. So our goal is to have a factory in each time zone within the next 12 to 18 months. Our second one, so we've expanded our California. Our initial factory opened 2.5 years ago with just one printer. That was our kind of R&D. We raised a pretty substantial amount of money last year, and we moved into the state-of-the-art factory where we tripled capacity. We now have approval from Colorado. Colorado wanted to bring more modular and basically off-site housing to the state, because they only had one factory and they have they have lots of people moving there from California and lots of need for workforce housing. People who work in ski resorts can't afford to live in the Vales and Aspens, on and on. There are a lot of big hospitality industry expansion. So Colorado ran an RFP, and we're very fortunate. We're one of the 8 companies that were selected to open our factory there. So we have the funding provided by the state, and we'll be opening it next year. And then we're hoping to find kind of similar type partnerships in Midwest and the East Coast. So it's really a combination of working with state agencies or developers to build a factory for us, but also having enough demand. I mean, basically our goal is to have demand for at least 100 homes will take us, we'll basically have a first 9 to 12 months of capacity. And we have strong interest from Ohio, Florida, in the Midwest. So, we're not ready to make announcements yet, but as 2025 rolls around, I'm hoping to at least get a couple more factories in the U.S. Strong demand from Canada. So we're hoping in this, and the Canadian standards, as you know, are a little bit different from ours here. So I'm hoping to have a factory in Canada. But there is demand from around the world. This year, in 2024, I spoke in Asia, Middle East, Africa, and in a lot of those places, we envision partnering, basically licensing our technology to local developers or contractors, because we're getting very good at manufacturing. Of course, we have a patented technology, and our material is our trade secret. So it's a little bit like a Coca-Cola model. Coca-Cola initially, when it grew, it set up bottling operations where they provide equipment to make the bottles and formula to make the material, but we want local partner to be responsible for marketing and installation, because in every one of those instances, you still need a general contractor to build the foundation and utilities and connect it. So great opportunities. And I really believe that Middle East, Europe, and Asia are going to be kind of our first, but that's 2026 and beyond. But yeah, I built a global company before my previous startup. I had operations on 3 continents. I had operations in Middle East, India, and UK. And so I have great connections globally. And it's just a matter of finding the right partners. And quite honestly, like in Dubai, for example, Sheikh Mohammed in Dubai publicly said that his goal is that for 25% of the buildings by 2030 to be 3D printed. A very ambitious goal, and they are very open to manufacturers from around the globe to come there. And so what they proposed is that they will give us 3 pieces of property where we can put our pilot units to determine, they can do local testing, and then also can determine what market adoption is. So I love that model. I love the idea of, putting some units out. Again, when you ship just 3 units, it's expensive, but still reasonable. And then going to scale.
Short lifespan, single-use plastic glazing is not a sustainable solution for daylighting. Solera is the glass-based alternative for the new millennium. Learn more at advancedglazings.com.
Yeah, with the 30% comparative cost reduction, you can deal with some shipping. There's no two ways about it. Yeah.
Right.
Okay. My God, that's amazing. So let's talk about limitations. Are there restrictions on footprint size, height, number of floors, those kinds of things?
Yeah. No, very good question. So far, we're just doing 1-story buildings. So now in my previous life, I developed multi-story apartment buildings. So we have a vision of how they can work in multi-story buildings. Quite honestly, we have enough demand, and it took us so long to get to where we are. So we're right now focusing on just 1-story. But in 2025, we will need to do some additional testing to be able to basically nesting them into multi-story buildings. And, they really are approved as residential. So they're designed to be at least 5 feet apart from another structure. When you go into multi-story, they'll be right next to each other. So we would need to do some additional fire testing to figure out how to put them next to each other in multi-story buildings. But that is a vision. I mean, in Japan, Hong Kong, Singapore, 50% of construction is done in factories. In the US, only 4%. I'm not sure what it is for Canada. So there is no reason why we should not increase the amount of modular construction in this country. And so, yeah, that's we have a R&D roadmap to figure out how to put them in multi-story. our buildings, we have real high ceilings, 10.5 feet high. So the limitation there, we couldn't go any higher because we have to be able to, since they're trucked, need to get under the
The
freeways or bridges.
bridges, yeah.
And between the unit itself and 3 feet of the ground for a truck, you cannot be higher than 13.5 or 14.5 feet, depending on part of the country. But still, 10.5 feet high, they look terrific, have a lot of air in them. Yeah, we've designed them to withstand the high wind, but we're still doing additional testing to exceed. We're seeing hurricanes are getting more powerful. So that's another plan for 2025 is we really believe that by attaching it, look, in a hurricane, the first thing that flies off is a roof. Here, the roof is printed as part of the building. But it's how we attach it to withstand higher winds. But we've tested them for earthquakes and fires and the snow loads. Again, we have different design for areas that have snow load, more of a frame than just more of a roof. So yeah, we've really thought. Look, I think the big advantage for us was we're contractors and developers getting into 3D printing business. Some people had struggles with the 3D printing. When you have people who come from engineering, more of a robotics experience and trying to figure out, they don't necessarily realize all the challenges and limitations that being a contractor you will face. We've really thought from the very beginning of how we're going to get the permits, how are they going to get insured, how are people going to get financed.
Yeah.
And so from that respect, our goal was to design buildings that are very much will meet all of the permitting, financing, insurance requirements. That was our main goal. That's why it took us so long, quite long.
Doesn't sound like it took you terribly long. Let's talk about permitting. Do you have issues every time you go into a new district, or has that gone smoothly?
Yeah, so that's a good question. By being a modular manufacturing is overseen by states. So we have to satisfy state regulators. People who do 3D printing with cement and who are working, printing on site have to get a permit from local municipality. So in our instance, owners, developers still have to have a permit from local municipality for the foundation and utilities and grading. But for the unit itself, it's a state approval. And 20 of the 50 states in the US allow third-party permitting, third-party approval process, and third-party inspection. So we can use with local entities that are approved by the state to approve our plans and approve the unit before it leaves. So even in that respect, being a modular manufacturer, factory offsite manufacturer, makes permitting much easier. The unit basically arrives with an insignia. It's like a certificate of occupancy. The local municipality just makes sure that it's attached to foundation. Yeah.
Okay. Now, let's talk a little bit about architecture. I want to swing back to this a little bit. Basically, you could create any shape. We talked about curves. And have you done that yet? Have you had an architect come to you with drawings and say, I want you to create that?
Architects are the most exciting about this process. And so the answer is, when somebody wants to buy just one unit, it's impossible to design something unique. I mean, yeah, it's possible to design unique, but it needs to be tested. It needs to be,
Oh,
but
I
if
see.
somebody wants to do 50 units or 100 units, we can really work with that. So that's kind of a solution. We have like 4 different design types on our website. And so the customers can find something that they already have in stock if they have a smaller order. But for developers and larger, I think they're just, it's imagination is a limit. So, and we ultimately, in order to be cost efficient, you just can't redesign it. And for any new design, it requires a test print. We use this digital twin technology so that when we print the first building, we scan it. It's mostly used in aerospace and automotive, but we use the same technology. So once you do the first print, you basically can scan it, can understand what is the most, where are some flaws. But it requires pretty large expense and time for the new design, but it's possible. So.
Yeah, that's really cool. That's really cool. Let's talk about how it's being adopted. You mentioned a number of places all over the globe. Is there any particular geography that's really jumped on this technology?
Yeah,
California. Okay.
vast majority of our customers are here, and I'm not sure that it's necessarily this technology. It's two things. It's just affordability, speed, and sustainability. I mean, lots of customers, when they hear about our sustainability, they get really excited. But the bottom line is still, people will not pay higher price to have a sustainable product. I mean, that's just, yeah, some might, but that's a minority. But people still want to have something that's cost effective and sustainable. And so they feel good about investing in something like this. But as I mentioned, interest is from all over. And quite honestly, so far, is some people are just, the shipping costs that keep people from placing an order. But we have a really roadmap. And the other thing is the gas prices are coming down. There's overcapacity in trucking. So the shipping costs, even as we've been working on this for the last 3 years, have really come down. So it looks much more favorable. So interest from all over, but initial shipments are up.
Okay, one last sort of main question. You talked about hurricanes a little bit. So, how do your homes compare to sort of a traditionally built home in those extreme scenarios? In hurricanes, tornadoes,
Yeah.
big snowstorms. Are you comparable, better?
Yeah, I really believe that they're better than traditional. So I mentioned this three-bone resort in Big Sur. In January of 24, we had first hurricane strength wind in California. So it was a 95-mile-an-hour wind, and the unit withstood very well. Again, the fact that it's a monolithic structure where pieces are not going to be flying off, that's what's very good. And then we can attach it. I mean, our traditional installation is attaching it in four corners. But for areas that are prone to hurricanes, just having more attachments and then having maybe triple glaze and hurricane shutters
Yep.
so that to protect the openings, I really believe they will do well. We will do additional testing because we want to comply with, like Miami-Dade County has the highest.
Yep.
They want to make sure that buildings withstand 150 miles an hour plus winds. And we're working. That's for 2025. We will have approval for that. So, but I feel very comfortable about it just because of the nature of how we print the structures and how we attach them.
Brilliant. Okay, we're getting close to the end, Gene. I'm going to ask you a question that I ask every single guest, and I ask them to answer from whatever perspective that they would like. What makes a great building?
What makes a great building is something that's beautifully designed. I really believe that. It's like, who gets excited about living in a house that looks just like 100 other homes in a neighborhood? And I really believe if you go to our website and take a look at our designs, the curves, the colors, can really make them very beautiful just from a pure aesthetics. But also what makes a great building is to have something that's very energy efficient and sustainable. So the fact that that you mentioned in your opening, we're using a material that fills our landfills. In a lot of places, people burn plastic. A lot of places around the world, they dump plastic in the ocean. So the fact that you can feel very good about the future. The other thing is this material, at the end of its useful life, I'm not sure what it is. I think it'll withstand, it's also pests don't like plastic. So it's going to be resistant to pests. But at the end of useful life, especially in some of these temporary structures, you can recycle the building itself. So, true circular economy comes into play. So in my mind, it's beautiful designs or unusual designs, and having, using sustainable practices is what I believe makes a great home. Something you can be proud of and something that's good for you and for your families and for the future of this planet.
Oh, that's fantastic. All right, before we go, Gene, do you have any announcements, any exciting news, anything that you'd like to share or promote?
Yeah. So we need to continue to raise capital. So in 2025, we're starting our next crowdfunding campaign, and people can go just to our website, azureprintedhomes.com, and usually there's a banner on the top. They can participate. We have over 2,000 investors in our company. So we started raising capital in 2023. So we basically, all the initial R&D, my business partner and I funded ourselves. So we're bootstrapped for a long time. Before we went to general public, we want to make sure that it works. But then 23, 24 were probably the toughest years to raise capital from venture funds. So we've done 4 different crowdfunding campaigns, raised over $2 million from 2,000 plus investors. But we also have some very sophisticated investors. So we have another 40 investors that are small venture funds, family offices, just your accredited investors. But the beauty of crowdfunding is people can invest from all over the world. So Canadians, Europeans can invest, and in smaller amounts. They can invest as small as $1,000 and become a partner. And lots of our customers come from also being a partner on the investment side. So it's, they really can. So that's going to be probably biggest. We are going to be announcing lots of new projects also in 2025. And so really exciting times. And if you just follow us on LinkedIn, Instagram, Facebook, I did a TED Talk that's been streaming since July. I've had close to 500,000 views. So people want to learn about us, and we're very transparent. And, if somebody really wants to see the factory, if they can contact me, and I'll be more than happy to give a tour if I'm in town.
This is really exciting, Gene. Thank you so much for making time to be on the show today.
Joe, thank you so much. You have a great podcast, and enjoyed listening to your interviews. So thank you so much for your time.
Yeah, it's my pleasure. Take care.
Bye-bye.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.